In this lesson, we will learn about a very important concept, which is method overriding. So what is method overriding? Method overriding is a feature in which a child class provides a different implementation to a method in its parent class. So we have a method defined in the parent class, and the child class provides a new implementation, a different implementation to it. So the signature is the same, so the method and its signature are the same, but the implementation is different. And like we understood in method loading, what does same signature mean? Same signature means that the method has the same name and the same parameters. So a child class provides a different, which means a new implementation of a method which was defined in the parent class, and the signature of the methods for both that defined in the parent class and the child class is the same. Let's try and understand it with the help of an example. So here we have a class parent, and in the class parent we have a method hello. So we have a method hello, and this method has no parameter. So the signature of this method is this. And then in the class child, which extends parent, we have a method hello, and what is the signature of this method? It is again the same. So you can notice that the signature of both these methods are the same, and this method has been defined in the parent class and has been defined in the child class. So let us see what will happen when we run some code. So we are saying parent p is equal to new parent. So we have declared a variable p of type parent and constructed an object of it. Now we are saying p.hello. So p.hello, so we're calling the method hello for the object p. So once we call the method hello, it will first check in the parent class. Do we find a method here? Hello? Yes. So what will happen? It will print hello parent. Next we are saying child c is equal to new child. So we are creating an object, a variable c, which is of type child, which is an object of type child. And then we are saying c.hello. So for the object c, we are calling the method hello. So it will start searching for a method hello from here. Did it find a method hello? Yes. So what will it do? It will do print hello child. And because we found the method here, so this method will not be called when we are doing c.hello. So this concept is known as method overriding, when in a child class we have implemented or defined a method which has the same signature as that in the parent class. Let's look at one more example. So in this example we have a class add, and in the class add we have a method named op. And what is the signature of this method op? The signature of this method op is int comma int. The name of the method is op, and it takes two parameters of type int comma int. And here in the child class again we have a method op, and what is the signature of that method? So in the child class what is the signature of the method op? The name is op, and it again takes two parameters of type int. So we can see that the signature of both these methods is the same. Let's now execute some code. So here we are saying add a1 is equal to new add. So we are creating an object, a variable a1, which is an object of type add. Then we are saying a1.op 2,3. So we're calling the method op for the object a1. So which method will get called? A1 we know is of type add. So it will check here. It finds this method. So this is the method that will get called. Int z is equal to x plus y. So what is x? X is 2. That's the parameter we passed. X equal to 2, y equal to 3. So z will become x plus y, which is 5. And what will get printed is add colon value of z, which is 5. Then we are saying add sq as1 is equal to new add sq. So we have declared a variable as1, which is an object of type add sq. And then we are saying as1.op 2, 3. So we're calling the method OP for the object AS1, and AS1 is an object of the type addSQ. So we'll start searching for that method here. Do we find a method that matches this signature? Yes. So this is the method that will get executed. So what will happen here is we will have x is equal to 2, y is equal to 3, and hence a will be 4 plus 9, which is equal to 13. And then what will get printed on the screen is add SQ colon value of a, which is 13. Then we are saying a1.op 3, 4. So we are calling the method op for the object a1. Object a1 is of type add. So we will look for the method. Do we find it here? Yes. And what will happen here? We are calling it for the values 3, 4. So x will be, when we are calling this method, x is equal to 3, y is equal to 4. So z will become 7. And what will get printed on the screen is add colon 7. Then we are saying as1.op 3, 4. as1 is an object of addSQ. So we will start searching for the method. Do we find the method? Yes, we found it in addSQ. So we will use this method. And in this method, x is 3, y is 4. So 9 plus 16, 25. So a will become 25. And what will get printed is add SQ colon 25. So notice in this case, we had another example of method overriding, because the method OP, which takes two ints, has been defined in both the parent class and the child class. Let's look at one more example. So here we have a class named place. We have a class named place. And what are the methods in class place? We have a method setName, which takes an object of type string. So this is the signature of that method. And then we have a method called print, which does not take any parameter. So these are the two methods defined in the class place. Then we have a child class named city. City extends place, so it's a child class. And what are the methods here? We have a method setPop. SetPop takes a parameter of type int, and then we have a method called print, which does not take any parameter. So notice in this case, the signature of the method print in both the parent class and the child class is the same. And then in both the classes, we have one different method defined. So setName in place and setPop in city. So let's now run some code and see what will happen. So we are saying place p1 is equal to new place. So we are defining a variable p1, which is an object of type place. And once it gets created, what will happen? The field name will become null. Then we are saying p1.setName India. So p1.setName means this method is getting called. So what will happen here? Name is equal to s1. So name will get the value India. Then we are saying p1.print. So p1 is a method of type place. So we'll start searching for the method in the class place. Yes, we found a method print. So what will happen here? It will print place colon, and what's the value of name? India. So place colon India gets printed. Then what are we doing here? We are saying city c1 is equal to new city. So we are creating a variable called c1, which is an object of the type city. And once we initialize it, what will happen? Pop will get the value 0. And from its parent, it will get the field name, which is null. Then we are saying c1.setName Delhi. So we'll start looking here. Is there a method called setName in city? No. Then we look in its parent. Is there a method? Yes, we found the method here. And it says name is equal to s1. So name gets the value Delhi. Then we are saying c1.setPop15. So we'll start looking for the method setPop for the class, for the object c1. C1 is an object of type city. So we'll start looking in city. Is there a method of type setPop? Yes, we found it. And we have passed a field 15 to it. So pop gets the value 15. Then we are saying c1.print. Now c1 is an object of type city. So we'll start looking for the method print. Do we find a method print in city? Yes, we found it. So what will happen here? We will create a string city colon name colon pop. So it will become city colon name. Name in this case is Delhi colon 15. So this is the string which will get created and printed. So notice in this case we had the method print which was being overridden in the child class. So the child class was overriding the method print of the parent. So that is how the name overriding comes in. So method print in the child class was overriding the method print in its parent class. Okay, so is this clear?